Alright, so let's go ahead and take a look at number 2. So number 2 is another situation similar to like number 1. They're giving us a story about something happening, and we want to kind of figure out what the pattern is. So to help us figure out the pattern, instead of staring at a bunch of words, it's nice to come up with a table, a little T-chart. That'll help us maybe trying to figure out what kind of pattern's going on here. So let's set up our table, and let's figure out what they're talking about in the problem. So Samantha's phone bill is fixed at $50 a month. Right, so $50 a month, that's important, right, because we're talking about time, again in this case, and time represented by months. And $50, we're talking about money, so we're talking about the cost of her bill. And then the question's asking how much would it cost, or how much would she have paid over 4 months, right? So, well, in the first month, she paid $50. Right? So 1 month she paid $50. And then what she's doing is she's paying $50 a month. So after 2 months, she would have paid another $50, which would be $100. After 3 months, she would have paid another $50, which would be $150. Right? Because we're figuring out the total that she's paid over time. So I know you look at that and be like, wait, so in the second month she paid $100? Well, no. We're saying how much total did she pay, right? So she paid $50 for the first month plus another $50, right, which gives you the $100. Another $50, which gives you the $150. And then another $50, which gives us the answer we're looking for, which would be $200. So our answer for part A here would be $200. But again, let's make sure we're clear on that. That's not that her bill was $200 in the 4th month. What we're saying is that over time, how much did she pay? Well, it is $50 a month. So after 4 months, she would have paid a total of $200. Right? And one word that we probably need to emphasize here that we didn't, this word right there, fixed. Right? So that means that it's not changing. Right? So the rate of change is not changing. It's staying the same, right? So we could think of this as a constant, right? Constant rate of change. Constant rate of change. And if we look at the pattern here as compared to the last problem, we see here that the number each time, what it's changing by, stays exactly the same. If you looked back at what we did on that first problem, you'll notice that, again, it wasn't jumping by the same amount each time. The jumps were increasing, whereas here the jumps are staying the same. So because the rate of change is constant, or because the rate of change is staying the same, then that's what we describe as something that is linear. And again, that word linear has line in it, and that's why it's a line, is because the rate of change is constant. So let's go ahead and put our description in here. So we would say that the function is linear. And you could look at it and say, oh, well, it's linear because if I graphed it, it makes a straight line, and that's true. But we haven't really graphed it here, and this is just kind of a generic graph. We haven't actually graphed our situation. The function is linear, right? Because the rate of change is constant. Rate of change is constant. Right? So that's what we really wanted to do in these first 2 problems, is be able to take kind of 2 real-life situations and find the pattern. Is the pattern describing something that changes by the same amount, like it does here? And if it does, then that means that we're talking about something linear, because the rate of change is constant. However, in the first problem, right, this is where we were looking at something that changed not by the same amount, but that it jumped by a bigger number each time. So that's where our rate of change is increasing. Alright, so go ahead and stop the video now and try number 2 on the right side.